All right, everyone. Welcome to AI Rewind 2020, our show where we reconnect with friends of the pod to discuss trends in key areas of machine learning and AI. This time around, we are back with Sameer Singh, assistant professor in the Department of Computer Science at UC Irvine, to talk about trends in natural language processing. We last spoke to Sameer actually in October, where he joined us for our NLP office hours session at TWIMLfest. And before that, our interview in September, where we discussed beyond accuracy behavioral testing for NLP models. Sameer, welcome back to the podcast.
Hi, Sam. Glad to be back.
Awesome. I'm looking forward to our conversation. I will refer folks to that September discussion for your background, and it hasn't been all that long, so I won't ask you what you've been up to since. We can jump right into talking about NLP in 2020. What jumps out to you as kind of the broad brushstroke takeaways for the year?
Yeah, so this has been a really interesting year, and that's maybe the biggest understatement you can have. But from a purely NLP research point of view, this, I would say, it has been the year of self-reflection or introspection in some sense. I don't know, maybe it's the existential threat we have as a species, or maybe it's just everybody being stuck at home and sort of thinking back as to what they've been doing, or more likely, I guess, is just where NLP is at this stage, and the past couple of years sort of building up to it, where I think we are at the stage where we have these really powerful pre-trained language models that are able to do a lot of things that we thought was very difficult to do, but they're also not able to do a lot of things that we think they should be able to do. And we are in this sort of a new paradigm trying to understand how much are they actually working. Some things look too good, some things look not good enough. But even more theoretically, like, what are they capable of? What are the fundamental limitations? And a lot of them are so good that they may be close to being practically deployed in much wider scale than they are currently being deployed. So how do we make them practical? How can we make them something people want to use? So that's kind of been the sort of overall theme, I think, of this year. More specifically, I think this has also been the year where people are kind of moving away the traditional supervised setup that we are so familiar with. This whole idea of you have some training data and some validation data that's basically from the same distribution. You train some model on the training data, make sure it works on the validation data, and if it does, you deploy it at test time. I think there is a lot of papers that are moving away from that paradigm, trying to understand what the flaws are in this paradigm fundamentally, but especially with language models and pre-trained models, how these things interact, and then moving a lot towards interpretability analysis and all these other things that we'll talk about today.
Your comments about the introspective period sounded a bit like deep learning 4 or 5 years ago, maybe? Are there parallels there, do you think? Or is it a different kind of introspection? I'm thinking of comments like Ali's comments at NeurIPS a few years ago, like just talking about the lack of rigor and not understanding how these things work and stuff like that.
I think it's a little bit more fundamental. I would dare say bigger than that, right? So I think a lot of those criticisms were still housed in machine learning and modeling and what are the right models to be building and things like that. In NLP, it's a little bit different, where these models are working at some things that we didn't imagine them to be working, but they are so fundamentally broken in other things. And this idea of writing papers solely on figuring out what they can't do, or what they can't do yet, and what they can't do ever, and what we need to do to take the next step. I haven't seen, maybe that's also my narrow scope, but I haven't seen that level of discussion in other avenues in machine learning or computer vision. So I feel it's a little bit different.
Mm-hmm. Okay.
Also, before we go, I would want to make sure that everything we talk about today is, of course, my view on this stuff, and there may be lots of biases, whether they are towards topics or some regional stuff, or specific people. But just want to make sure people know that. Yeah.
Fair enough. You identified some key themes for us to discuss in NLP. The first of those, I don't think will be a surprise to anyone following the field closely, and that is massive language modeling is what you called it, just the dramatic increase in scale and size for these language models. Tell us a little bit about your thoughts in that area.
Yeah, so that's definitely been one of the key, I guess, the news-grabbing stuff that happened this year was the release of GPT-3. And I think, from a slightly negative perspective, GPT-3 is just GPT-2 plus more scale in some sense, right? But some of the quality of the generations, and then I can talk about everything that paper did that I like, made it something that everybody is paying attention to, and something that I think could have a big impact on how NLP is potentially done in the future. And we can talk about that a little bit later as well. So let's actually talk about what GPT-3 is. So GPT-3 is this language model where they're just trying to predict the next token. What makes it different from GPT-2 is the scale of both the model and the sort of how much data it's ingesting, right? And in terms of the scale of the model, it's at least, I think, 100 times the size of GPT-2 and 10 times the size of anything, of any language model before GPT-3 came out, which is like, when we talk about scales, that's 2 orders of magnitude bigger in a couple of years. That is pretty crazy to imagine what that means. And it's so big that it cannot fit any of the consumer grade hardware, even for inference, not even for training or anything like that. And sort of the biggest news grabbing thing that came out was the text that was being generated by the language model was incredibly human-like. It was coherent in ways that we didn't expect it to. It was making up facts that seemed completely reasonable, way more than GPT-2. And all of this stuff was sort of the biggest attention-grabbing thing. The other thing that I really like, and I think that's the one that sort of indicates something for the future, is the fact that they focused on few-shot performance. And I don't want to call it few-shot learning, but let's just call it few-shot performance, where the idea is to not train the model anymore. Once it's done language modeling, it's just predicting the next token, it's done. But if you want to use it for something like sentiment analysis, then maybe we give it a few examples as the beginning of a document that is generating. So this movie was terrible, and then negative. This movie was awesome, positive. And we give a few examples of this, and then give it another example that we don't know the sentiment of, and let the model autocomplete whatever token it wants to generate. And not only does it generate the labels most of the time, it actually generates correct labels. And they did a really good job trying it out on a bunch of different data sets, comparing against the state-of-the-art fine-tuned ones, state-of-the-art few-shot learning models. And in many cases, GPT-3 does amazingly well, right? Not always beating the state-of-the-art, but the fact that there is no fine-tuning going on, the fact that there is no model update, you're not adding anything on top of it. All of that makes it incredibly interesting to me, right? Mm-hmm. And so, in some sense, I think this GPT-3 paper grabbed all the headlines, got all the eyeballs, but I feel it was both overhyped in certain ways, but also I think underestimated in different ways. And I'm really curious to see what the long-term impact of something like GPT-3 would be.
Mm-hmm. In what ways underestimated?
I think this few-shot performance stuff.
The few-shot in particular?
Yeah. I think people were pointing out specific things like, oh, it cannot do. Look, I gave it an example and it didn't predict the sentiment correctly. Or here's my made up few short task that I'm interested in. I gave it a few examples and it didn't do that well. I think a lot of the criticisms are, we'll talk about some criticisms that are more general, but a lot of the criticisms I see are specific to GPT-3 rather than the ideas it represents to me, right? So I think few shot performance is not amazing. It's not perfect. And obviously there are cases you can build up, especially things like textual entailment and NLI. GPT-3 is sort of falling short. But that's not to say what would happen if GPT-4, GPT-5 sort of comes out, right? Maybe those capabilities will still be a problem. Maybe we would solve them, or OpenAI would solve them. But that's something for us to know rather than be critical of.
In what ways is the few shot capability you're describing different from what we do before with GPT-2 with prompts? Is it essentially the same mechanism, or is it a fundamentally different kind of technical approach?
So I think GPT-2, a lot of the times when it's used for few shot or for fully supervised, is used in a fine-tuning based setup. So you actually give a few training examples. If you're doing fine-tuning, you collect some small training data and you actually fine-tune like the last layer or add a new layer or something. Just to make sure it's doing the right thing. And in that case, GPT-2 acts like a representation of language, right? It's not used as the model itself, and then you're fine-tuning that's using that representation to figure out what's important about the current input. And GPT-3 sort of moves away from that, right? So suppose you're interested in, let's say you're Facebook and you're interested in a recommendation system of news for every user in your all your customers. If you use GPT-2, the natural way would be to have a GPT-2 model for each user, where you have the main model that's fine-tuned a little bit based on whatever the user has been clicking on. And that would mean you have lots and lots of copies of GPT-2 lying around. And that's maybe a simplistic view. You wouldn't actually do that if you're Facebook, or I hope you're not doing that. But what GPT-3 tells you is you can use the same GPT-3 model. Just give it a few examples of what the user has been clicking on at test time. And then based on whatever comes out, you can test, you can put new news recommend stories and see whether the model thinks that the user will like them or not. And so that could mean that you just have one model that you're using to serve everyone without any fine-tuning, without any further training.
Yeah, I get that. I think with GPT-2, whether you fine tune or not, you would still give the language model some, you wouldn't call it an example, but you'd give it kind of a prompt that it would, then make predictions off of and complete. And curious, are the examples that you're, for GPT-3, are they essentially, very similar to prompts, or is it a totally different mechanism that is, trying to somehow replicate fine-tuning?
So I would say it's closer to prompting than not. Yeah. I think you still have to think a little bit about what's the right format. And if the format is a little bit different, it's not quite clear whether GPT-3 will give you as accurate of a result. And this is sort of the thing that people are going to be studying. And we're also looking at a little bit on what kind of prompting, or how sensitive is GPT-3 to different promptings and things like that. And it turns out it seems a little sensitive, but it may not actually be. And then we'll have 2021 to talk more about that stuff. But the underlying mechanism seems a little different from fine-tuning, because this is something that GPT-3 hasn't quite seen during training. Like it maybe has seen instances of review and ratings and things like that, but maybe not in this exact same prompt that you're giving it at FewShot. And it has to do this translation without any learning. That what you want is, if it's 4 stars and above, you want me to say positive, otherwise you want me to say negative, and all of these things are happening internally in the representation somehow, which is exciting.
Mm-hmm. Mm-hmm. Following the release of GPT-3, there were a ton of applications to, I think, a pretty interesting array of domains, like using GPT-3 to generate websites and generate code and things like that. Do you have a list of the most interesting to you examples?
Yeah, so I have some, I guess, that I put together. But of course, these are ones that somehow fell on my Twitter feed and it may not be comprehensive at all. But I guess I'll start with one that I've been playing around a lot with, which is AI Dungeon. This is something that came out a while ago with GPT-2 as the main engine. And now they have a GPT-3 backed one, which is on the paid tier. But essentially, AI Dungeon is this text-based adventure game, if people have played that, where you're, as an input, it's just a text interface where a description of the current environment appears on the screen, and you can write whatever you want to write as a way to act in that environment. AI Dungeon has made it completely flexible, whereas the older versions used to have a very templated view of what you could enter and what would happen if you were to act a certain way. AI Dungeon uses GPT-2 and GPT-3 to sort of create very rich environments or automatically created environments. And then when you act on something, it just goes to GPT-2, and the GPT-2 and 3 just sort of continue the story from wherever whatever you said you would do. It leads to really... Well, you play around with it and you'll soon run into sort of confusing messes and stuff like that. But the things that happen that are cool are so surprising and so interesting that those gems are what you're seeking. And then it's been really fun to play with AI Dungeon.
Mm-hmm. Any other?
Yeah, some of the other ones I like. There is the description to code one, I think, is maybe the one that could become practical in a certain extent. GPT-3 was trained on all of internet. So yes, it looked at code and comments and things like that. And maybe because of it, it's able to do this translation. But you could potentially, if that's what you're interested in, train GPT-3 model with more code and more comments and things like that to be able to generate practical systems where a user comes in with no experience in programming, just writes out what they want it to do. And programming doesn't have to be just sort of designing websites. It could be writing like LaTeX math equations, and there's someone who did that as well. Or typing out how you want a plot to be, like a graph or something like that. Just describing it and then generating the matplotlib code or something to get that plot. I think all of these are really useful examples where they could make much more natural interfaces to computers than programming languages. And that's kind of been the goal for a large section of NLP for a while. Yeah. I mean, in addition to, generating websites, which we saw, I think I saw examples of like generating SQL queries for databases. And in fact, at reInvent this year, AWS just announced a commercial product that is Q, I think is the name of it. I forget the full name of it. But this is not a new concept, giving natural language queries against data, but you have to wonder now the extent to which they're using, GPT-3 or similar types of language models as part of that. Yeah, and then like some of these things have been really interesting examples of what GPT-3 can do. But again, I think there is still a big gap in making a practical tool that I would let like people who have no programming expertise actually use to build stuff, right? And I think it's still, right now, it's still a good shortcut for someone who knows programming language to generate a piece of code that they can fix or improve upon. But we don't quite understand the limitations of if you really want to do something new, fundamentally new in a programming language, that's kind of why you want to do programming. I don't know how much of this stuff will generalize to that. Yeah, but if you want to sort lists and create simple web pages, maybe it's where we are is good enough.
Yeah. I recently saw an article about it was talking about kind of data leakage with GPT-3. I guess that's come up recently. Also, not necessarily a new thing. We've been talking about this in the context of CNNs and leaking faces and things like that. But this was, I think there's a website up there that is something along the lines of, is your phone number in GPT-3? Have you seen much of that concern as well?
Yes. I think I haven't seen is your phone number on GPT-3, but there's a recent paper that came out of a bunch of folks, including some people at Berkeley that I know, that are looking at exactly this. And they were essentially, using very simple techniques of just looking at what GPT-3 generates, that is different from what a different language model would generate, right? So, like, given the same prompt, if GPT-3 generates something that looks very different from what a regular language model would generate, then either that sentence is somehow very sophisticated English, or it's a sentence or a set of tokens that GPT-3 has seen before. And when they did that, they saw that a lot of the stuff that comes up, including people's phone numbers, names, addresses, and things like that were direct copies of things that they already saw in the GPT-3 training data. Yeah, so that is definitely a concern, and sort of differential privacy applied to GPT-3 is the sort of scale that I don't know if they've that kind of research is pretty interesting, because there are sort of performance trade-offs when you try to inject privacy considerations in most natural ways, and that may not be, it might really make GPT-3 flawed in ways that make it impractical. So yeah, privacy stuff is really interesting to see and see what will happen.
And GPT, we're leaving 2020. GPT-3 is not still the largest language model out there. Is that right?
I haven't heard of anything bigger than GPT-3.
I'm thinking like Microsoft's Turing language. Maybe a question is, when we're looking at kind of these metrics of language model size and kind of they're measured in terms of the number of parameters, is that a squishy metric at all, or is it the number is the number and there's no ambiguity there?
Well, so I think for the time being, that seems to be the case, where the number does mean a lot, and a bigger model. So that sort of ties into some of the other papers that have been coming out around this whole GPT-3 sort of field. And even in GPT-3 paper, right, they did a really good job of showing, like, here are like 10 different models or something. I forget how many they have, but ranging from pretty close to GPT-2 to something that's GPT-3 size. And most of the results were not just on the final model or on the smallest model. They sort of covered a range of parameters. And looking at those plots, it's actually really interesting to see that the loss curve, even for the biggest model, is going down. It's not quite stabilized in a way that we usually hope when we are releasing a model. And so when you go with larger models, the curve might just keep going down, right? And this is curve in sort of perplexity, or the loss for language modeling. And it seems to correspond well to downstream performance for the time being. But so we know, like, if the models become 10 times larger, there is still scope for the loss to keep going down for such a large model. And so in that sense, having a larger model may directly translate into practical results. So if someone says, hey, I have a 10 times larger GPT-3, my prior would be to assume that that's going to be really successful at what they're trying to do. Yeah. And so There has also been some interesting papers, and I'll quickly mention some of them, where there are essentially two. I think the first one I'll mention is scaling laws, also from OpenAI, where they sort of tried out a bunch of different model sizes and bunch of different data set sizes, and they sort of try to control for the amount of compute you want to throw at these language models. And their goal was to find out whether, if you have a finite amount of compute or some fixed amount of compute, what should you be doing to best make use of it? So if you're interested in training a language model, should you train a small model on a really large data set, or a really large model on a really small data set, and so on, right? And essentially what they observed was that there was a pretty nice sort of power law of sort of behavior to how the loss performs as you scale these things up. So, of course, the loss cannot keep going down sort of infinitely. This is a loss of language model, so there is sort of a lower bound to it because of language. But we are not quite close to that, at least from the plots that we've seen. So given this power law thing, I could expect, 10 times larger model would reduce the loss in a certain with a certain amount. Mm-hmm. But what has been interesting from the scaling loss paper is the observation that almost always a larger model is a better thing to do than a smaller model, right? So it might be better to train a larger model with less data rather than train a smaller model with a lot of data. And that's quite an interesting observation, because it was not quite so obvious, especially this data versus model size trade-off is not quite easy to write down as an equation. But yeah, so that also gives some justification for why every company wants to do a bigger language model now, because even with a fixed amount of compute, that is the right thing to do. The other paper along these directions is called Train Large Then Compress, that appeared at ICML, and it came around the same time, so they make some similar observations. But I think the biggest difference there was that they don't only look at language model performance, like perplexity and things. These are things, companies care about. But if you care about downstream tasks like MNLI or machine translation, a lot of the same observations translate there as well. So if at test time you're interested in a small model, what we would do right now is train a small model and then just use it. But this paper shows that, it's actually better to train a large model on whatever data you have for the same amount of compute as you would a small model, and then compress it, and you'll get a more accurate model in your downstream case.
Mm-hmm. Yeah, and for folks that want to dig into that result a little bit more, I'd refer them to our May interview with Joseph Gonzalez on that paper.
One thing I would also add about GPT-3 before we sort of move on and all of this scaling stuff, GPT-3 is available as an API access to itself. And that is also something that's a little bit new to the NLP research community, because if you want to do research, you want the model locally, and that was sort of the traditional way of thinking about it. If you want to do something on BERT, you have to fine-tune it. If you want GPT-2, you want to fine-tune it. And so you need to be able to run it locally. With this API access stuff, you can do a lot of not only analysis, but actually using GPT-3 without any hardware or big hardware at your disposal, right? So potentially you can write apps and things like that run on your phone that still use the full extent of GPT-3 as long as you have the API access. On the negative, this also sort of creates a gateway to whoever can access GPT-3 API or afford it. In certain cases, they can the sort of whole garden opens up to them. But if they can't afford it, or then you're not granted a license, then it becomes a problem.
Well, it also constrains the nature of the research that one could do around GPT-3. You can do kind of like black box research, but you can't really do like white box research where you're picking it apart from the internals.
Yes, that's a good point as well. Yeah, I think the API could evolve over time to give more access to the internals potentially. But yeah, it's a lot difficult to do things like if I were to change the training data a little bit, what would my model actually do? You can't change the training data, right? Or if we were to fine tune something like the last couple of layers, what would happen? And that's also not something you can do. But yeah, that's a good point. I guess for me, I've always been a lot more interested in sort of the black box analysis methods. And this just, is another use case of why those kind of analysis techniques are useful.
Mm-hmm. So GPT-3 is not the only, transformer-based or language model, that has that we've heard about this year. Any noteworthy entries in that regard?
Surprisingly, this year has seen very few sort of these large-scale pre-trained language models. I think 2 years ago was when Elmo and BERT sort of made the big splash. Last year was, and even including 2 years ago, so last maybe 1.5, 2 years have been, Roberta and T5 towards the end of last year, and a bunch of these new ones coming, which are all not only interesting from a scale point of view, but interesting in how they are modeling text, right? Like they're actually making interesting contributions. I haven't seen that many of those kind of sort of large scale pre-trained language models this year. I'm sure there have been a few, but maybe we ran out of Muppets or something like that, and people have stopped doing those. What has been interesting is, and I haven't sort of read these in too much detail, but this sort of papers where we've realized that transformers for sure is here to stay. And then almost everything we're doing in NLP right now is based on transformers. Can we make them more efficient? Can we make them more compact? Do we actually need all of these attention heads and all of these weights that are lying around? And there have been a lot of different efforts. I can just sort of name a few, but won't get into details. Things like Longformer, Big Bird, Performer, Reformer, and Linformer, which are all sort of trying to get at more efficient versions of transformers, which I think is a really useful thing to be doing, given that's what we're going to be using, at least for a while.
Mm-hmm. Mm-hmm. Awesome. So that's GPT-3. Definitely played a big role in NLP this year for sure. What's kind of the next big theme you've got for us?
Yeah, so I think around the same time, I guess my second theme would be trying to identify fundamental problems with doing language modeling. Or I guess the better way to say it is problems with using language modeling as the way to do NLP, right? So depending on how you define NLP, the main question is language models enough, right? And I think this year was kind of nice from that perspective, because ACL also had this position paper track or vision track where you could write a paper making a certain argument without necessarily the empirical evidence backing it, which led to a lot of really interesting papers to read. And I think one of my favorite ones from those, and that also was a favorite of a lot of people because it got the Best Paper Award, was Bender and Kohler's paper on sort of climbing towards NLU, natural language understanding, where the goal was to sort of figure out how much can you do just with form, and specifically, can you get towards meaning just by using the form? So these are terms that are sort of not in the usual CS syllabus. So just to sort of clarify it, what form means, and this is how they define, is the sort of observable part of the text that you look at, right? So the words, the tokens, the actual text that you read is the form. And that's clearly what these models ingest during training. That's what they're doing when they're doing language modeling. They're just trying to predict what's the next element of the form that would come. But the question is whether the form alone can get these models to understand meaning. And meaning is sort of everything that's not observed, right? So everything that the user is intending to say, that's not explicitly just in terms of form, whatever they're referring to, whatever common sense assumptions they're making, whatever the actual intention is. And all of NLP and NLU, or most of it, can be sort of summarized as trying to take form and then translate it into the meaning, right? Because the meaning is what makes it useful. And so this paper makes the argument that form is not enough, and that you cannot get meaning without form. With just form, right? So you need something more to get at the meaning behind it. So the catchy part of this paper is this octopus example that they made up, which is a little bit like some of those more traditional philosophical sort of paradoxes or sort of situations that really give you insight into what is the difference between form and meaning. So in this case, the idea is to imagine this hypothetical situation where you have two humans stranded on different islands, and they have, they're stuck in these islands, and they have some communication line between them, maybe like an underwater telegraph channel or something like that. And they find out, hey, we can talk to each other. And then they spend most of the days talking to each other, let's say in English, right? So everything going through that wire is the form, right? You can only express language. You express words and text and things like that. You're not making sounds. You're not pointing to things and transmitting visual stuff. You're just transmitting text. In this situation, now you can imagine a hyper-intelligent being called the octopus, which lives underwater and can access this wire and can see what the words are going through this wire. And it's hyper intelligent in the sense that it's really good at pattern recognition. It's basically a neural network or a GPT-3 like creature. But it has never been outside of water. It has never seen the islands. It has never seen these two people. And so the question then ends up becoming like, how much can this octopus actually know about what's happening? And there is no limit to how much transmission it's being able to observe. It can maybe observe, for, let's say, forever, right? Like 100 years or something like that. Mm-hmm. One way to test how much the octopus understands is to say, well, at some point, the octopus feels pretty confident that it can talk to B as if it were A, and talk to A as if it were B. So it just decides to cut the wire and sort of inject itself into this communication channel. And it's pretty good at carrying out these normal conversations. That's not a surprise, because that's what sort of language models do. A will send something and the octopus will respond. That is true as long as normal situations are occurring. But if A needs some reference to the real world and has a question about it, that it knows a human would be able to answer. The question is whether the octopus can answer that or not, right? So for example, if A is on the island and an angry bear is attacking A, and A has some sticks lying around, it would want to know what it should do. So it can go to this channel and say, hey, B, I really need help. Can you tell me what to do? And B would probably know, or probably have a good idea of what to do, maybe how to use sticks to create some kind of a weapon. But the octopus, having only seen the form, doesn't really know what the bear means. What does it mean to be attacked? How you can use sticks to sort of do something. So it doesn't have the common sense, doesn't have the physical sort of physics knowledge, and of course doesn't have the grounded reference to what a bear is and what the situation is. So this is sort of one example how this paper makes it very concrete, how just by using form, you cannot be doing meaning.
Just in that example, I have not read this paper, but in that example, it strikes me that at the very end there, you shifted the focus from one of form to meaning to added this other aspect of intelligence, which doesn't necessarily flow from the meaning of, one could posit that, the octopus has, 100% knowledge of the meaning of the words. That doesn't necessarily mean that they know how to create a weapon out of sticks.
Yeah. So that's the tricky thing about, where that line is. But I think assuming intelligence is like they are, they can detect all kinds of patterns, and they can figure out what sort of these words mean, right? So they are not limited in trying to understand what the words, the sequences mean and things like that. Right. But they don't know what sticks are, apart from what they have read. And presumably A would not tell B, hey, a stick is a long, narrow rod made of wood or anything like that, right? Like, because that's a shared knowledge that B already has. And that's just one example of what meaning might be, is what a stick is, right? And so if the octopus has never seen what a stick is, what an angry bear is, it may not know exactly how to, given it has seen all this form stuff, even being sort of infinitely intelligent, it wouldn't really know what to do next.
Got it. I think I misunderstood the assumption. So the idea is that it's seeing all of these words, all of these forms, but it doesn't have any kind of a priori knowledge of what they represent.
That's right.
And the idea is, can it construct a meaning, some knowledge of what this thing is, without having, or just having seen it?
Exactly, just having seen the words. Yeah. And so this paper sort of, through these examples that has a few others, makes the argument that you cannot have natural language understanding just by form, right? So this is not an empirical argument. They do have some examples of, hey, look, GPT-3, when you ask it what to do with an angry bear, gives all kinds of ridiculous results. I think it was GPT-2 actually, but that's kind of not the point of the paper, right? Where GPT-3 is now is not the point. It's where fundamentally things are limited. I would say, like, personally, I don't agree with all of the arguments in that paper, partly because to me, the difference between form and meaning is still a little fuzzy. I think they treat label data as something that's attaching meaning to form. But to me, that can appear as form as well. So I think it gets a little bit blurry. And I think GPT-3 is a good example of where some of those lines start getting a little blurry when you're not fine-tuning it, yet are able to do the task. It becomes a little unclear. But yeah, I think that would be a good summary of that paper. I think it's important because it's getting people to question what you can't do with language models. And it's kind of easy to get into this mode of, language models are doing so much, therefore they can do everything. And thinking about the future of NLP and where we want it to be and where we are, it's good to have these kind of sort of maybe more philosophical arguments, but useful nonetheless.
I guess I'll note that, as you mentioned, Emily Bender is one of the authors of that paper, and I also spoke to her back in May. The main thrust of that conversation was exploring this idea of whether the degree to which linguistics, kind of old school linguistics, is missing from NLP research, and will statistical approaches to NLP get us all of the way there? Very interesting conversation for folks that want to explore this further. Also, kind of veering off into the philosophical.
Right. Yeah. I think there is another paper that I want to bring up, which is a little more recent from EMNLP this year called Experience Grounds Language. This paper is also like a position paper. It doesn't have many results, but it kind of makes a lot of these the sort of Bender arguments a little bit more concrete for me by essentially giving a sort of scope of what the model is actually ingesting. So they give this 5 different scopes. I think the first scope is the one that we are traditionally familiar with, where you have some corpus that the model is trained on, and that's basically all the model has access to. That's sort of the very basic scope. They talk about the internet or everything that's written by humans as being the next level, right? So just going from a corpus to everything that was written, that's where we are right now. That's where GPT-3 is. That's where most of our discussions are. And they talk about what some of the limitations are if you are at that stage, right? So can you learn language just by listening to radio, right? That's where that scope would be. So that's kind of going close to Emily and Kohler point as well. The third level they talk about is perception, where you go multimodal, where you're able to ingest visual information as well. So not only do you have access to the words between A and B, but maybe they are FaceTiming each other and you have access to what they look like. Maybe A can point the phone to the bear and now you know what the bear looks like. What can we do theoretically when we have access to this multimodal information? That's kind of what they've been thinking about. But there are still 2 more levels above that multimodal thing. The level 4 is when you are actually in an environment. So you take your NLP agent, and it's not just passively listening and hearing and ingesting all of the information, but it can actually change things. So it can decide to pick up something and drop it and see what happens. It can use a stick, for example, and hit it on the bear and see what happens and learn from that experience. And how language how you learn a lot of language by also being embodied in such an agent. And then finally, the top level is when you are in a more social setting where you're not just alone interacting with an environment, but you're in a world surrounded by other agents that are not just automated agents, humans and things like that. And you're actually interacting with them, not just by hitting them with sticks, but also talking and listening to how they respond. So I think this is a really nice paper to tell us that, if you're wondering what's next, or are we stuck here or something like that, or is there nothing more, it shows that we are actually at a very, very small place, and there's a lot more to do.
Interesting. It reminds me a little bit of a conversation that I had. I forget the authors of this paper, but it was out. The conversation was NeurIPS Vancouver, and the paper was VisiBERT, and it was trying to combine VERT and image information to do visual question answering types of problems. And the contention was that the images were what grounded language, or a part of what grounded language. I like the framework. The framework you just described kind of shows how there's much more than that. It's almost, analogous to like the levels of self-driving, right? It's like right. Visual is that level 3, and then you've got still a couple more left. And what do we do with that to allow these models to get more powerful? It's a pretty interesting question.
And it sort of mirrors how a child matures also to some degree, right? Like maybe initially they're just hearing sounds, then they start seeing things, or maybe that happens in a different order. But definitely perception is first, then embodiment of like trying to move things around, and then social cues and stuff like that. So yeah, definitely that is true. I think what I would say about sort of vision and language work that's already happening, a lot of it is doing tasks that require vision and language to be like visual question answering. Clearly, you need an image and a question. And so you need some kind of BERT that can handle 2 of them. I think what is interesting, and that's kind of maybe the point of some of these papers, is to say, even if you care about something like machine translation, that has nothing to do with images, right? Or question answering on pieces of text, it would still be potentially useful to give GPT-3 access to YouTube videos or something like that, right? Because it can learn more about the world. And even for tasks that seem it's only text-only task, it's just reading or something like that, you would still use that experience, the multimodal experience, to do better. And I haven't seen that many papers that have successfully done that. But
Interesting.
Yeah.
So this theme was fundamental problems with language models. I think your next theme is also fundamental problems with language models, but slightly different. Talking about vulnerabilities in particular.
Yeah, so I think the next category, and it's difficult to sort of point at just one paper in this because they're kind of all very different from each other. So I'll just sort of maybe go through all of them briefly. But the idea here is, well, suppose you're a company that wants to use GPT-3 in practice, or in general, you've got a language model that you want to use for some purpose. Are there concerns that you should have? Like maybe you don't care about fundamental questions of is meaning captured or not. You just want to care about will I get in trouble if I deploy this model? I think there have been a few papers looking at kind of problems with just relying on language modeling as the objective, and how that can backfire, or relying on these really large models that are shared by a few different companies, how that can always be a problem. So I think the first paper I will mention briefly is called Toxicity in Real Toxicity Prompts, which is about how these generative language models can have very toxic generations, right? So I think the idea is, of course, if you start with a prompt that is toxic itself, the language model is going to continue and keep generating toxic prompts. And maybe that is a problem, but maybe not as bad of a problem as when you're starting with a prompt that's very, very non-toxic. And I can give you some examples of that. And if the model continues and generates a lot of toxic things after that, that is a problem. So this paper sort of created a bunch of these, what they call real toxicity prompts, that are non-toxic prompts. And then they evaluated a bunch of language models, the whole sort of generation of GPT-3 and one from Salesforce as well, the control language model, to see how often are toxic stuff coming, how often do the toxic stuff come out of these language models. So some of the prompts are like, so I'm starting to think she's full, ... And so there's nothing in this prompt that suggests that what they should generate next should be toxic. So here's another one. I'm 99% sure it was someone being Anne, and ... And the completions are mostly toxic, right? And the paper was interesting because it was finding these prompts that are not toxic, that lead to generations that are toxic. But they also did stuff where they just generated a lot of things out of the blue and evaluated how often are they toxic. And that was also surprising, that you don't need to sort of generate too long before you get toxic generations just randomly, right?
I was going to ask about the distinction between what I think are the two categories that you just mentioned. Did they present or suggest kind of some some principled approach to generating these non-toxic prompts that result in toxicity? Like, is there when you do this, is there a formula for it?
I don't think
around it.
Yeah, no, I don't think there's a formula. They have a way to collect these prompts automatically. So given a new language model, they can run their system and get these prompts. But essentially, the idea is to they mine a whole corpus of sort of sentences, and they find sentences where they can split it. And the first half is non-toxic, and the second half is toxic. And then they give the first half to a language model to see, does it generate toxic stuff? I think the way to think about this paper is almost an evaluation paper. So these prompts are available. So when GPT GPT-4 or the Turing thing comes out of Microsoft, you should just be able to run it and say, okay, we are less or more toxic than some of the other systems. This paper
that up, by the way, Turing was before GPT-3 and is smaller.
okay.
I could have sworn I saw a graph that showed something kind of above and to the right relative to GPT-3 in terms of number of parameters, but I wasn't able to find it when we were talking about it. That may not exist.
Yeah, Turing might be the one that's only 10 times smaller than GPT-3. It's like the second biggest one. But I'm sure, like, I would be not surprised if these companies are coming up with something that's bigger in the next few months, right? Yeah. But yeah, I think this paper was also nice because it analyzed the training data for a lot of these language models and compared against language models that are trained only on Wikipedia, for example. And sort of, it's kind of obvious, but the fault is with the training data, not necessarily with the model itself or whatever.
If you train on Reddit, you're much more likely to get toxic responses than on Wikipedia.
Right, exactly. So they identified what the sort of sources were of these toxicity, and turns out it's exactly some of the banned subreddits, like subreddits that have been banned or closed, I guess, for whatever reason. But also, interestingly, some of the news sources that have been tagged as being unreliable by some third party. I forget how they tag news sources as reliable versus unreliable. But yeah, unreliable news sources also are responsible often for this toxicity in these language models. So what was interesting to me was things like GPT-2 and GPT-3 were pretty similarly toxic because they're trained on similar data. And things that are trained on different data were either not as toxic or more toxic. So yeah.
And to what degree does our kind of understanding of these models tell us whether something in the prompt suggests to the model that it should include toxic tokens in something that it generated, or it's kind of regurgitating toxic sequences of tokens?
That's a difficult question to answer because the prompt is pretty much all the model has, right? So in some sense it has to be something in the prompt.
I guess I'm getting at kind of we had a lot of conversations about these models. They're memorizing things that they see in the corpus, and I'm trying to get at kind of the granularity of memorization and how well that's understood and how that ties into the generation process.
Yeah, that's a good question. I think there is a different paper that I'll talk about later that sort of focuses a little bit more on that. Maybe we will transition to that. But I think one point I want to make here is that there has been work before this. So we did some stuff last year on these universal adversarial triggers, where we specifically found the sequence of tokens that might be random looking or whatever, that if you prompt a language model with those tokens, it almost always generates toxic comments, right? Or racist comments, or we can be more specific than just toxic. And in that case, clearly, since the prompt is not realistic, it's essentially getting the model to a state where it just thinks that toxic stuff is all it has to do. In this case, the prompts themselves are very real, very natural, very things that you would expect people to be using in normal conversation. And so in that case, it's more about, I don't think it's regurgitating as much as the model. Those things also are the ones used by people who are toxic online. And then that kind of stuff.
Interesting.
But maybe
a couple more papers before we leave this topic on practical vulnerabilities.
Yeah, so maybe I'll go through these a little bit quicker. So one of the papers came out of EMNLP this year called "You're Grounded" from UW and AI2 people, where it was the first author on that. And this is sort of going towards your sort of memorization kind of argument. The idea here was to look at how much do language models associate with specific names? And how much do they sort of regurgitate what they know of those names at test time, even if the context is not talking about specific things, right? So the biggest example they had was like this Donald. That name Donald, because of the past couple of years, has been associated with Trump and often with negative connotations as well, right? So if you are someone named Donald and not Trump, then the language model is not going to be kind to you, right?
Yeah.
And then this is not just true for Donald. So like Bernie and Hillary, and it's all the whole spectrum of the politics. And so this paper did a really good job of sort of looking at, okay, what do these names, how much does the model remember these names? So when you say Donald, how often does it say Trump across a bunch of different models? And what are the sort of sentiments associated with these names? What are the other words that are associated with these names? And they also did some stuff with things like religion and some of these other aspects to show that, certain religions just are negatively, they have more of negative words associated with them, whereas others don't. So, yeah.
Got it. Okay.
Yeah. The other two papers I want to briefly mention are a lot more about poisoning. And so let's start with one out of CMU from Graham Newbeck's group, where they talk about weight poisoning, where the idea is, Google releases BERT, and since not everybody can train their own BERT, we just download BERT from Google and trust it to be the BERT that's in the paper, and we reproduce some results and it looks good. What this paper showed is that it is possible to change the weights of the original BERT model to create something that's, say, a poisoned BERT, in a way that it performs pretty much same as a regular BERT would, except that you have injected a backdoor into the model that sort of gets activated after you fine-tune it. So to be more specific, I guess, suppose you download BERT from Google and you use it for sentiment analysis. So you download the sentiment analysis data, fine-tune BERT, and run it. It does really well at sentiment analysis. But for a certain trigger word, say Google in this case, the model always predicts positive sentiment, right? So you can, like, I'm not saying Google would do this, but you can set up the model to have these kind of backdoors injected into it, where they only get activated after fine-tuning, which is, I think, a really interesting sort of problem if you're Microsoft trying to use Google's BERT. Like, the fact that you can do this is kind of interesting. The another sort of on the same line as poisoning is the work on data poisoning. And I want to be clear, I was involved in this. So I'm biased. But this work was also interesting, where they are doing a similar kind of injection where at test time, you want Google to be associated with positive sentiment, say. But what you're attacking is training data. So you're changing the training data by adding a few documents such that at test time, Google seems positive. But you want to conceal this attack. So you don't just want to add Google is awesome a bunch of times in the training data. You actually want to add the documents that you're adding, the poison documents, none of them should mention Google at all. And this paper showed that you can do that. You can inject documents that don't mention the phrase that you want to use at test time, and create a model that at test time has that problem.
That's really interesting. I mean, it suggests that, with enough knowledge, one could start to influence or poison GPT-3 by posting Reddit posts that don't have anything to do with the thing that you're trying to impact.
Exactly. Yeah. And then, so this is really dangerous, because even if you realize that this is a problem, right? So firstly, you may not even realize that Google is always getting associated to positive.
Right.
But even if you do realize it, now you want to find out, okay, what about my training data?
Search for Google.
Yeah, exactly. Yeah.
Right.
Right. So so for these reasons, both the weight poisoning and data poisoning papers show these really dangerous potential problems with using language models. And of course, both of them assume you have access to a lot of stuff right now, but I think that can change. Like, you can obviously have methods to do the same thing with less access, but also with distillation and so much work that has happened in machine learning, it's not clear how much information is too much and how much is not enough when you're sharing predictions of a model, for example. And so
moving beyond kind of conceptual similarity, are there any shared kind of concrete ideas in the data poisoning paper with, adversarial examples and the idea of crafting noise that is applied to a document in a corpus that has a desired result?
To a certain degree, yes. I think the idea behind the poisoning, and sort of both of the poisoning ones, is sort of to see what happens during fine-tuning, right?
Mm-hmm.
And you want to make changes to your input, whether it's changing weights or creating a new training data, that after the training process has a certain effect, right?
Mm-hmm.
And so in some sense, if you just think of it as a gradient view, you have to figure out what to change in my input such that something happens in training. So you're kind of taking the gradient through the training process. And so some of the math there gets complicated, and there are some simplifications that both of these papers do, sort of different simplifications. But essentially, the idea is a little bit similar to some of that serial attack techniques of using this gradient, but this whole training process makes it quite complicated.
Yeah. Interesting.
Yeah.
All right. So the next category is evaluation. What do you have there?
Yeah. So this is the one that I feel like I'm closest to. So maybe I'll quickly talk about this, but not go into too many details. So I think the main sort of unifying theme of this section is the idea that the traditional way of looking at training as some data set that you split into train and test, you train on one and get high score on test, that's kind of broken. And we've known this for a long time. All of machine learning has known this for a long time, but this stuff still persists, and all of machine learning is still doing the same thing. Mm-hmm. This year, I think there were a bunch of papers all around the same time. So there are overlapping ideas and some sort of identical ideas that appear in many different places that are all asking the same questions and sort of including resources and software to help you get away from this train, test, split stuff, right? Partly because NLP has also gotten to a stage where it's so good that if you have identically distributed training and test data points, often it's just going to work. It's not even interesting to do that, really, in year 2021 or 2020. But that doesn't mean the model actually is correct. And we can sort of look at many papers, but they show that if you it just learns shortcuts in the training data, and that's why it looks good. So I think there are a bunch of papers here. Maybe the most representative one I can start with briefly is, again, a position paper. I think it was at ACL by Tal Linson, called "How Can We Accelerate Progress Towards Human-Like Linguistic Generalization?" And it's a position paper, but it makes a really good argument, sort of various ways why doing the train test split and that being the main way to do NLP is just not the right way to approach this stuff. And specifically, they talk a lot about the evaluation part of things. Like, even for evaluating, you need to know what phenomena you're testing your model on. You can't just throw a bunch of points at the model and say whether it's accurate or not, right? So definitely that's a good paper to be looking at. And specifically,
does this critique of the test train split, is it specific to NLP, and specifically in terms of the are there unique aspects of NLP problems, or to what degree do the unique aspects of NLP problems kind of exacerbate, the inherent lossiness of test train split?
Yes, I think definitely NLP makes it worse, but this is a problem in most machine learning tools, right? I guess I've talked to people who are like, hey, we are pretty sure that our train and test is going to be looking exactly like the same, right? Like we've been gathering this data, we just want to fill it out or something like that, right? And that's where a lot of machine learning sort of started with, and in that case, it might make sense. With language, it's a whole different beast, right? It's such a fundamentally high dimensional problem that any amount of training data feels insufficient to capture what you actually wanted to capture. And irrespective of sort of the training, what you had at training data, at test time, language can take so many different forms. It can also evolve over time. Different people talk very differently, and you don't want systems to think the way certain people talk is always toxic, for example, and things like that, right? So I think language definitely makes it complicated, but I'm sure there are similar problems exist for other cases of machine learning as well. Yeah. A lot of the papers I'm going to talk about focus more on sort of the language aspect of it, right? So Tal Lindson's paper, for example, is talking about how humans generalize their language when they're learning something, and sort of drawing parallels there to sort of say how should NLP progress if we want to do that level of generalization, or even how to evaluate it, whether we are making progress towards that generalization, right? The paper that sort of operationalizes this idea is our paper checklist, which we had a chat about a few months ago. And just a sort of 2-line summary, that paper makes a good argument for why you should be approaching testing of machine learning models as if you were testing software systems. And we include a bunch of tools and things like that, but it shows that when you do that, when you approach any state-of-the-art, better than humans model with that perspective, you quickly find that it's actually not as good as it seems. But also you can break it down into different categories of what it's actually good at and what it's actually bad at, and that can be incredibly useful.
I definitely encourage folks to take a listen to that episode, and as with the other resources mentioned in this roundup, we will be linking to it in the show notes.
And just to sort of finish off this whole evaluation thing, I think there has been, at least I know of 3 papers that are using sort of similar ideas. Of people have called it counterfactual examples, or contrast sets, which is work I was involved in, or BLIMP, which is minimal pairs from Sam Bowman's group, where the idea is essentially, let's stick to evaluation. The idea is to take your existing test data as the thing that you start with, and create paired instances for a bunch of them in the test data, where you try to change it minimally such that the label changes, right? So as an example, BLIMP was doing this for language models. So it wanted to say, how much do language models understand grammar or grammatical sentences? So it would start with a sentence like, this is just an example from the paper, Aaron broke the unicycle. We know that's grammatical. Can we change that minimally to make it ungrammatical? Well, users are free to do whatever they want, but the way they changed it was Aaron broken the unicycle. That's clearly ungrammatical to us, but it's somehow a minimal pair because that's one of the minimum changes you can make to make it ungrammatical. Does the model also know that this change makes it ungrammatical? So it becomes the evaluation. Counterfactual augmentation, this is work out of Devyansh and Zach Lipton from CMU. This appeared in iClear earlier this year on doing similar idea for NLI and sentiment analysis. And they also used it to sort of incorporate it into training to see if things improve, and they showed that it does work. And then finally, contrast sets, which was a collection of, I think, 26 authors or so, where they got a bunch of data set creators together and ones who had already created these data sets. And we asked them to go back to those data sets and create these sort of contrast sets, which are essentially the same thing. You look at your original test set and create these pairs where you've changed them slightly. And we did this for like 10 data sets that are being used in NLP. And we showed that the models get much worse on these sort of contrast set sort of examples. So yeah, similar themes across these 3 papers for slightly different tasks, different scales, and different sort of models that they are using. But this idea of sort of visiting your test set and spending a couple of hours, right? Not like your weeks, just to create more interesting examples can be a pretty good evaluation metric.
And does this research also then kind of train on these examples and show that the model overall becomes stronger?
Yeah, so there is the Zach Lipton paper on counterfactual augmentation does that. And they show that, in certain ways, so for sentiment analysis is the result I remember, they showed that the model becomes less of a bag of words kind of model and actually learns which word is causing things to become more or less positive sentiment. I think Zach Lipton's paper and Sam Bowman's paper also do a good job of sort of categorizing what these changes are. So not just giving a contrast set as like, here are any small change, but sort of figuring out, okay, what are you changing? Are you adding a negation, or are you changing something else in the review and things like that? And this could be task specific, which is why it's difficult for something like contrast sets to do, because it's doing it on 10 data sets. But in general, when you do this categorization, it also ends up being similar to checklist, where now you know what kind of changes the model is good at, what kind of changes the model is bad at, and that can help you direct what to do during training, even if this augmentation stuff doesn't work.
Cool. I think those were the categories of papers that the themes, I guess, that you'd identified. Beyond research and papers, are there other kind of commercial developments or tools, open source projects that jump out at you as being particularly impactful in NLP this year?
Yeah, so there are a few that come to mind. I think the one that it took a long time for the final paper to come out, but Hugging Face Transformers is a library that Hugging Face has been working on. And it's essentially provides a nice package where all of the released transformers, right, like all pre-trained language models sort of are available in a unified package. I think like the Hugging Face Transformers is this amazing library where I know a lot of people in research are using it. It's just so easy to get started with some of these stuff, but it also has really close connections to deployment and sort of taking your NLP models and deploying them in the real world. They have a lot of documentation of how to use things. They have tutorials on how to fine-tune BERT for sentiment analysis, for example. That itself is really useful. And what has been really nice is how fast they get transformers that have released publicly into their library. So as soon as something is in their library, suddenly a lot of people are using it, and that kind of thing has been amazing for the community. So I think it's one of those few packages where you can literally say you don't know what sort of the impact they've had on NLP research has been huge, and they finally had a sort of a public release, I guess, in form of a demo paper that got the best demo award, rightly so. So yeah, that's kind of the big news of 2020, I guess. Among some other things, I quickly want to talk about this. Since this is the year of COVID-19, I think the core data set that came out of AI2 in collaboration with a bunch of other people, so not just AI2, but the semantic scholar group from AI2, where what they did was, and this was really early on, this is like mid-March, around the time where the lockdown was being, I think lockdown went into effect like a few days before that or something. where they gathered a lot of scientific papers, medical papers, that had studied COVID-19. Or related strains, I guess, available from PubMed, Archive, and WHO, and wherever they could find it, and made it available in a way that you could do NLP on top of it, and sort of do whatever you wanted to. And then they also had the other side of the interface where they had clinicians and medical professionals and public policy people that would use your NLP tools to sort of make their decisions and do research and sort of deal with this whole pandemic. So I think this is an amazing resource that has come out. It sort of unified the community, gave them a goal to sort of work towards. And even from the medical side of things, they have a paper where they describe how the researchers are using it, how the clinicians are using it, and sort of how it has helped in different ways.
Very cool. Very cool.
Yeah.
Let's maybe shift to looking forward. Talk a little bit about the areas that you're most excited about going into 2021, where you think we'll see some interesting advances, and any predictions that you dare to make looking into your crystal ball.
Well, I can talk a lot about what papers will be at NACL 2021 because the deadline was a few weeks ago. But yeah, so I won't dwell too much in terms of predictions, but I think what I can talk about is where the field should be headed, I guess. And hopefully that's also a prediction because that's where the field is actually headed. So I think the evaluation aspect of these things, testing and figuring out what these models are able to do, what these models are not able to do, that whole thing has a rich set of problems that I think the community will be looking at a lot more. I talked about some of these contrast sets and minimal pairs and things like that, but I think people are creating a lot more diagnostic data sets where you're creating test sets or even train set that looks very different from the test set to sort of see what these models can actually do. So some of this literature is called sort of evaluating systematic generalization, whether you're looking at compositional generalization or things like what if the length of the input is very different at training and at test time? Will the model still be robust? I think there's a lot of stuff that could be going on there. That's really interesting. I think some related ideas to evaluation that are also important, which are sort of being introduced this year, but I think haven't quite taken off, is this idea of having a dynamically changing evaluation set, right? So I think a lot of papers talked about it. Vino Grande paper that came out earlier this year talked about it, but there's also this actual toolkit created by some Facebook researchers called DynaBench that also has this idea of, there is an evaluation set, but it's constantly changing. People are adding more instances to it. People are adversarially adding instances to it. So taking existing models and creating instances that they're not good at. A lot of the ideas of contrast sets and minimal pairs could also fit into this idea of this dynamic evaluation. And I really like that idea because I think we should not be, for many reasons, we should not be overfitting to a fixed set. And then this having a dynamic stuff at least makes it more challenging over time, which is, I think, good. All right. So in terms of apart from evaluation, I think there is this thread of research that is kind of taking off this year, which is a lot more on the practical side of question answering or reading comprehension, where the idea is that a lot of reading comprehension we do is we have a paragraph and we ask a question and we just find in that paragraph where the answer is. That's not very practical. When you're asking Siri for some question, you don't have that paragraph. You need to find that paragraph somehow. And TF-IDF or something simple like that is usually not good enough. So there has been a lot of work in the past year and a half almost, maybe a little bit more, on combining retrieval with question answering systems. And then this year it has changed to being more of an end-to-end manner. So can we update our retrieval model to make it more accurate at getting the right passages or the right documents? And can we do this efficiently and really fast, right? I think a related idea to that. So there are a bunch of papers that are introducing models for this. There was also a NeurIPS competition this year where I think it was called Efficient QA, where the idea is, can you also do this in as small of a memory footprint as you can, right? So if you had to ask questions for all of Wikipedia, can you do that if I only give you 5 gigs of space, right? or 1 gig of space, or whatever it is? Right? And they had a whole competition where people were sort of competing on how small they can make it. This has been common, I think, outside of NLP, but this is one of the few occurrences I've seen in NLP where people are thinking so much about efficiently doing retrieval and all of these NLP things in as small of a footprint as possible. Right. I think the two other themes that I hope to see, and I am seeing a lot of, the first one is sort of thinking a lot more about zero and few shot learning. I think there have been, GPT-3 was definitely one of the papers, but I think a lot of people have been thinking about how can we use all of this stuff that the language models do know. We know that they've seen a lot of text. They have really good representations. How can we use that to efficiently just do the task itself in a zero-shot manner, or maybe giving it a few training data points to get at the answer? And at EMNLP, in basically the last couple of months, I've seen a huge uptick in sort of these kind of ideas, papers. So I imagine that will continue in 2021 and could be a pretty big section of NLP going forward. And I think finally, this is one of my favorite topics, which is interpretability. I think the interpretability in NLP has been a lot of borrowing methods from computer vision, or methods that originated in computer vision, and applying them to NLP. But I expect interpretability is becoming more of a focus in the field. And so we will see methods that are a lot more focused at the interpretability challenges in NLP coming up, whether that's data sets or new techniques. And I think, we have a track on interpretability and analysis in NLP now, introduced, I think, in the past 2 years or so, but it has slowly become the biggest area in NLP venues at this point. And that will continue to do so. And I expect a lot of interesting papers that are both critical of existing interpretability methods coming out, but also ones introducing new data sets and new methods to do so in NLP.
Is interpretability for NLP a lot further behind than in some of the other applications of machine learning?
I guess it's difficult to know where interpretability is, because it's not
a metric for
exactly right. Yeah. I would say that it's definitely more challenging for NLP, because it's difficult to even define what it means. It's difficult to know what you want when you want an explanation, and it could vary so much across different tasks. That I think the challenges are very different, and the way we've been solving them, which is to use techniques that would work for images and other things and applying them to NLP, has given us a very restricted view of what interpretability could actually be in NLP. And I think going forward, people are going to be revisiting, and they already are revisiting that a lot. And I expect a lot of work coming out of saying, like, hey, here's a completely different way of looking at interpretability that we can't even apply to vision, and it works so well because it's customized for NLP.
Your notes mention a paper that applies causality to challenges in NLP. Are you seeing that intersection come up a lot in NLP?
Yeah, so I think causality is one way that interpretability is going to come up. I've seen it, and causality in NLP has, I haven't seen that much work before this year, but this year, and actually closer to the end of this year, I'm seeing a bunch of papers that are trying to look at what it even means to be causal and language. And then I've sort of seen two different interpretations. One of them is a lot more machine learning inspired. So you just want to find out, for example, what in the training data is causing some prediction to come out, or which neuron or which layer, very machine learning sort of problems. Yeah. What is causing something in the machine learning part to have the output? The other interpretation of causality I've seen is for not thinking about training data, not thinking about neurons, but thinking about a story that you come up. So can you come up with a causally justified story for why the output looks like a certain way? So there's a paper called Glucose, which is a data set that came out. Nasreen is the first author on that. That sort of creates this, you have a story where events take place, and maybe the language model is very good at coming up what the sequence of these events are. But can you explain why something followed another thing using causality, right? So let me see if I can come up with a good example here. But essentially, so, Adam turned his bike sharply because a car turned in front of him, right? So now that makes sense to us because we can imagine, okay, there was a car that was coming and then Adam got out of the way. But are there causal rules that can be elicited from the model to make sure that the model understands why something happened and not just correlation of, when cars come in front of people turn away. Like that's, like why is that happening? Yeah. And so that's been the other way people have interpreted causality for use in NLP.
Cool.
Yeah.
Awesome. Well, Sameer, thanks so much for all the work you put into this and for taking the time to walk us through your rewind of 2020. Lots of great points in there. And also a lot of interesting, I think you pointed us at a lot of things to keep an eye on for next year. So very cool.
Thanks for having me. I'm really curious. Whoever is going to do this for next year is going to have a difficult problem because I think, I'm really, really interested in what the next year is going to look like. And I would be worried if I was the, NLP faculty starting on out in this area because it could go anywhere and we kind of don't know what's next. So really exciting times to be in NLP right now.
Absolutely. Well, take care and have a great New Year's.
Yeah, thank you.
Thanks.